All right, if you remember back in conics, we have these funny shapes called hyperbolas, where there's two options. There's a horizontal hyperbola, which I have first as this equation on the top, and then there's a vertical hyperbola, which is the equation below it on the bottom. Well, what's the difference between the two of them? That's one of the most important aspects of this. A horizontal hyperbola has negative y's. A y, one with the negative y, or the one with the y, or the one with the y, or the one with the negative x. Negative x. Well, the shape is horizontal. Shape is horizontal. So, and when I say that, I'm looking at this. See this shape right here? These big curvy lines that go like that. This is a horizontal hyperbola. So that means we can knock out this vertical equation. We're looking for equations where the answer has a negative y, which means right away I get to cross out one of these equations on the left. See this one? Where to go? Where's my negative x equation? There it is. That guy, in my example, gets crossed out because it had a negative x. See that right there? I know that's not going to work. That would be the shape of a vertical hyperbola. So right away I've ruled out one of these things. And next, I'm going to need to use information about the center of the parabola. The center, let's put that right here with a nice big dot right there. Where's that located? That's going to be h comma k. That's my center. And it's located at, from the looks of it, -2 in x and +4 in y. Okay, well, the way you express that in this equation, remember, here, let's bring this equation down here and write it with those h and k values in it. That would be x plus 2, watch that sign flip, divided by a squared. I don't know a squared yet, we'll get to that. And then y minus, y minus 4 squared, divided by b squared, which I don't know yet, equals 1. Okay, well, which of these equations match? It has to have x plus 2. So I know it's not this one, and I know it's not this one right here. So I've got two real choices left. And the last piece of information is interesting. Look what it tells me about this. And it passes through the origin. Okay, that's interesting. Right here. Get your attention right over here. That is the origin, where x and y both equal 0. Well, that lets us do something kind of interesting, which is that if you plug in x and y being 0 into this equation, then it should equal 1. Okay, well, let's try that for the first one. I'm going to say x equals 0, pi by x, and y equals 0, pi by y. Is that equation true now? Well, here, I don't have room to write up there, but let's write it down here. Is 4 divided by 1 minus 15 times 16 divided by 4 equal to 1? Nope, not going to be that one. So that's not true. Well, there's only one equation left, and if you're pinched on time, you go ahead and put that equation in. But let's double check it here to be sure. I'm going to say x equals 0 and y equals 0. And let's evaluate this equation at the origin and see if it works. So that's going to be 4 over 1 minus 3 times, what do I have, 16? That's 4 squared over 16 equals 1. Well, is that true? That's like saying 4 minus 3 equals 1. Looks good. So this is our equation right there, which we captured by using information about the center, about the orientation, right, that horizontal vertical shape, and this neat little bit about the origin.